Example 8.5. MKZ Airlines is planning a project investment, the purchase of 3 Cessna aircraft to fly a specific route. The cost of acquisition of aircraft, including all charges, is as before $2 million. It's expected, however, that 1 year net revenue from operations will be $650,000 or $0.65 million, and this will continue for 3 years. So the cash flow is always going to be available at the end of the year. The aircraft at the end of the 3rd year will be sold for $800,000, so $0.8 million. And the alternative opportunity cost of capital is investment in safe bonds, which is 3.5%. So let's show the cash flow diagram. On the cash flow diagram, the axis is a time axis. So time t equals 0, end of the first period, end of the second period, end of the third period. At the beginning of the cash flows, the CF0, or cash flow at time t equals 0, is minus $2 million spent in investing in the project. And then thereafter, we get 0.65 million or $650,000 at the end of the first year, the end of the second year, and the end of the third year. But at the end of the third year, we also get an additional $800,000 or $0.8 million because we sold off the aircraft. So capital disinvestment has happened. This is a cash flow diagram for this particular project. Now let us find out the present value of the positive cash flows and the net present value of the investment. So this is example 8.5. So we have minus 2 million. But now instead of 650,000, so we'll have to say time t equals 0. So this is time. Actually, let's just do it properly. Let's just take this from here to here. Okay, we use the same column width, Control C or EST, enter. So same format, which is the millions format. Time t equals 0, 1, 2, and 3. So let's cut that and paste it one cell down to represent time and cash flow I at time, or t, time t, and cash flow at time t equals t. So at 0 is minus 2 million, at 1 it's 650, at 2 equals 650, at 3 equals 650 plus 800,000. The rate of discount is 3.5%, and so we have to find out the present value. So we can do this using 2 methods again. So let's just use the most straightforward. Equals cash flow divided by parenthesis 1 plus rate, and fix that. So $n $1, $n $1 to the power of 0, to the power 1, to the power 2, to the power 3. And then if you want the present value of the cash inflows, just add the present value of the inflows, which is 2540, comma separators please. Sure, comma separators, and Alt-OCA, which is format column autofit. So we can see the present value of cash inflows is $2.5 million, PV underscore CF underscore T. Present value of cash inflows, actually just PV underscore CF. Inflow. How about the NPV? NPV is the present value of cash inflows plus the minus of present value of cash outflow, which is $2 million. So the net present value is 542,618, and it is positive. So we've calculated the present value and the net present value. So it has been approximated in this example as 540 instead of 542,618. So that's the only approximation we've used, but it's the same answer. So that's example 8.5. Thank you for listening.